Hi Hamza, how are you today?
Yeah, I'm good. Thanks.
Okay. Are you ready to start the interview?
Yeah, that's fine.
Okay. So the first question, can you see the graph here?
Yeah, yeah,
Yeah,
I
is
can.
that clear? Right. Can you describe the graph to me, please?
Okay. So yeah, hi, I'm Hamza. And so this graph, it is so there's an initial kind of rapid increase in the oxygen saturation
Mhm.
um, when the partial pressure increases, and then that ends up plateauing.
So this candidate shows a really good description of the graph in front of him. He describes the sigmoid shape. In terms of how we can make this answer even better, what I'd like to see is some sort of basic description of what we're looking at even before we've started. So for example, the candidate could have said, this is a graph of partial pressure of oxygen against the essential saturation of hemoglobin, and we can see a line graph has been plotted. Something like that will give the examiner a bit more of a confidence steer that you know what you're talking about. On top of that, when they're describing the graph, it would have been useful to throw in key figures. For example, when the candidate talks about the graph plateauing, it would have been nice to say that it plateaus after 60 millimeters of mercury. And if you increase above 60 millimeters of mercury, that's when we see this plateau. So little figures like that really show that you're understanding and engaging with the material in front of you.
And why is the graph this shape?
So I think it's to do with oxygen binding to the hemoglobin. And what it's showing is it's showing that at low partial pressures of oxygen, a slight increase in that oxygen level will lead to a large increase in oxyhemoglobin present. And this is because of the fact that it's much easier for oxygen to bind to the hemoglobin molecule. Um, but by the time it gets to the high partial pressures, because most of the oxygen binding sites will be full, it's going to make it slightly more difficult. So there's going to be that restriction where it can't get to that 100% level as easily at the high levels.
So again, the candidate shows a really good basic understanding of why the graph is this shape, but he feels a little bit unsure. In order to help you in that kind of situation, go back to your basics. What exactly is hemoglobin? It's a molecule consisting of 4 polypeptide chains, with as well as some heme subunits, and each polypeptide chain sort of binds to one molecule of oxygen, and therefore the whole thing binds to 4 molecules of oxygen. The second and third molecules of oxygen are easier to bind because of cooperativity, and it's really important to get those key terminology across if you happen to know them. So, in terms of improving this answer, I'd say make it a bit more clear what we're talking about at the start, mention those key terms, and just say things with a bit more confidence.
Why would you say that this is advantageous for humans to have this with hemoglobin?
Well, um, I guess it means that at low partial pressures of oxygen, which are found in sort of the actively respiring tissues that are going to need the oxygen, it means that the oxygen will um, dissociate from the hemoglobin and go and provide itself to the tissues that are going to need the oxygen for respiration.
Mhm.
Whereas, but it also means that at really high partial pressures of oxygen, even small decreases aren't going to make a huge difference. And that's why we have a flat upper portion. So it means that it takes a significant lack of oxygen to start having a change in the body's ability to kind of take up oxygen and use it.
So, this is the strongest answer from this candidate so far, I think. At 3 minutes in, we're talking about the plateau and we're talking about why it drops off, and we're explaining why that's important at both ends of the graph. Both because we're sort of resistant to changes in oxygen partial pressure at the top end, as well as when we get to the muscles when the oxygen partial pressure is slightly low, we want to be offloading that oxygen a lot more quickly and a lot more easily. So, overall, this candidate shows a good explanation of both ends of the graph.
How would you describe or draw the effect of carbon dioxide on the shape of the graph?
Uh, I think with carbon dioxide, there's a shift to the curve will move sort of to the right, because what happens is that carbon dioxide then competes with oxygen for the hemoglobin, and because carbon dioxide has a higher affinity to oxygen to the hemoglobin than oxygen, it means that the carbon dioxide will bind more strongly to it. So I guess this is more helpful in respiring tissues, because it means that, again, when there's high carbon dioxide in respiring tissues, more oxygen is dissociated, because and so that provides more oxygen for further respiration.
So here the candidate runs into a little bit more trouble. We start talking about the affinity of carbon dioxide for hemoglobin and how it's greater than oxygen, and this may be being a bit confused with carbon monoxide. Now, in reality, carbon dioxide binds to many different areas of the blood, and in particular, even different areas of hemoglobin, so it's a bit tricky to start talking about its affinity for hemoglobin as a whole. What I would be more likely to say is just focusing on the shift of the graph and throwing in again the key terminology such as the Bohr effect, which is mentioned later on. So if you know that term, absolutely use it, because it's really going to show to the examiner and the interviewer that you know what you're talking about.
How might this graph that you see be different in a fetus?
Let me think. So I know that in a fetus, obviously, they take their oxygen from the maternal red blood cells because they don't have lungs to actively respire themselves or to actively inspire. So the hemoglobin is going to need to have a higher affinity for oxygen. So I think I'm going to guess that it probably shifts to the left, because it means that at the same partial pressure of oxygen, there is a higher affinity in fetal hemoglobin, so that the oxygen dissociates from the maternal red blood cells and donates itself to the fetal red blood cells, and that means that oxygen then can be taken up for the fetus for them to do respiration for growth.
So this is a classic Oxbridge question. We start with something that you're quite familiar with, the hemoglobin, and then we take it to a place where some candidates feel a bit more uncomfortable, in this case fetal hemoglobin. What's important, like this candidate does, is to think through the steps in terms of the physiology and why things might be the way they are, and that will lead you to a lot of the key answers. Now in this case, the candidate does a good job of talking about the shift of the curve and exactly why that might be needed. In particular, I like the tie back to why oxygen is needed in terms of respiration and growth of the fetus, because that shows that you're really thinking about the scenario in front of you. Where I think this is a weaker answer is sort of in the terminology and the vagueness in which the candidate talks about certain things. For example, we say something like maternal hemoglobin donates itself. That really technically isn't correct, so be careful with statements like that. On top of that, I would like to see a bit more about the fetal physiology and how exactly the placenta works. For example, it's not the maternal blood cells which are crossing the placenta, it's a diffusion process. So giving a bit more information about things like that would have shown me that this candidate really knows their stuff. So all in all, on the positive side, I like how this candidate thinks through the answer and thinks out loud. On the negative side, the terminology is a bit sloppy and I'd like to see that a bit more refined.
What other factors affect the oxygen carrying capacity of blood?
So I think obviously the amount of red blood cells, because if you have less red blood cells, then you can't carry as much oxygen. What else could there be? Oxygen maybe that's dissolved, because that might affect like the concentration gradients and diffusion ability from the lungs to the blood. Yeah, I think that would be those would be the core ones.
So here the candidate is quite quick to jump in, and what I would say about this is they're quick to jump in, but then they tend to lose ideas and lose steam later on in the question. So in order to avoid that in your interview, make sure you take a couple of seconds at the start just to think through your answer. It's perfectly fine, and in fact the Oxbridge tutors tend to want you to take a moment on yourself, think through it and come up with an intelligent answer rather than just jumping in with the first couple of things that spring to mind. Now in this case the candidate does mention some good examples. The amount of red blood cells, the amount of oxygen dissolved in the plasma, those are both key examples. What I would say is also for the candidate to push themselves a little bit more. For example, they mention that the amount of red blood cells is an important determinant of the oxygen carrying capacity of the blood. However, they don't mention any situation where that might change. For example, if you're anemic, if you've lost a lot of blood, if you go up to a higher altitude, you actually end up with more red blood cells. All of those things put an interesting physiological strain on the body, and the interviewers, above all else, want you to come across passionate and interested in the topic that you're discussing. So if you can throw in these extra things, answer the question, but then extend yourself a little bit more, it's going to separate you out from the other candidates that they're interviewing.